Alright, section 6.2. In this video, we are going to talk about circles and polygons. Alright, so I'm just going to kind of quickly mention a couple characteristics of circles and polygons, then we'll do some application problems. So, as you can recall, a circle is a set of all points in the plane that are certain distance from a fixed center point. So that means when we draw a circle, we got to have a center. All right. So from the center to any point on the circle, that's considered as a radius. Okay. So we got to have a radius in order to draw our circle, plus a fixed point. All right. So the distance from the center to any point on the circle is called the radius r. The diameter d. Okay. The diameter d is the length of a line segment that passes through the center of a circle and intersect the circle at two different points. So from any point on the circle to any point to another point on the circle, as long as I pass through the center, okay, that is called a diameter. Okay, that line segment is a diameter. So let me quickly write this down too, just in case I don't have it. So to find the area of a circle, okay, I think a lot of y'all probably remember area of a circle is always pi times radius squared. To find the perimeter of a circle, or so-called the circumference of a circle, it will be pi times diameter. Okay, we'll do a couple example of the area and circumference here just in a minute. All right, polygons. Okay, a polygon is a closed figure that is determined by three or more straight line segments. So three sides. If I have a polygon with three sides, we consider those as a triangle. Triangle is our very first polygon. All right, four-sided shape. All right, will be called a quadrilateral. So under quadrilateral, we can have parallelograms, we can have we can have rectangles, square, trapezoid, and so forth. Okay, any four-sided shape is called a quadrilateral. Five-sided is called a pentagon. Six-sided is called a hexagon, so on and so forth. All right. This one called a convex polygon. A convex polygon is a polygon in which all interior angle measures less than 180 degrees. Okay, if all angle within is less than 180 degrees, it's called a convex polygons. Concave polygon. Concave polygon is a polygon with one or more interior angles that measures greater than 180 degrees. So again, this word come up twice now. Interior angles are angles that are inside the polygon. So if I have all the angle all the interior angles that are less than 180 degrees, then it's called a convex polygon. If one or more interior angle that is greater than 180, like this one will be greater than 180, then we call those a concave polygon. All right, let's do some example real quick. So make sure you watch out. Make sure you read carefully what it's looking for here for the circle problem. Find the circumference of a circle. So circumference, as I mentioned earlier, is pi times diameter. So let's use 3.14 for pi. That will be 3.14 times. Whenever we're dealing with a circle, you got to know what the problem given me for the circle. So from the center to any point on the circle, the 34 centimeter is my radius. So diameter, okay, is actually made out of two radius. So that will be 2 times 34, which will give me 68. All right, so pi times my diameter is 68. Round to the nearest hundredth, so 3.14 times 68. That'll be 213.52. All right, centimeters. All right, let's practice the area formula. Given the following figure of a magnet, how many square centimeters? So whenever we see the word square, in geometry, that means finding the area. So let's find the area. So area of a circle is pi times radius squared. So that will be 3.14 times. So here, from the center of the circle to any point on the circle, that will be the radius. So my radius is 10 centimeters. So that's what I needed for my formula. So 3.14 times 10 squared. 10 squared. All right, exponent is a caret key, so that will be raised into the second power. So that will be 314 square centimeters. All right. Now, this formula is for finding the sum of the measure of the interior angle of a polygon. So I mentioned something about interior angles earlier. So this is for finding the sum of interior angles. So the sum of the measure of the interior angles of inside the polygon is always going to be, okay, n stands for how many sides a polygon has. So you take the number of sides of a polygon minus 2, then times by 180. So if I have a 15-sided polygon, what will be my sum of interior angles? So that will be 15 sides minus 2, then times 180. That will tell me the sum of interior angles. So parenthesis 15 minus 2, then times 180. So 15-sided has a 15-sided polygon. The sum of interior is 2,340 degrees. Okay, so all 15 angles. Okay, 15-sided means 15 interior angles. All 15 together is 2,340 degrees. All right. The measure of an interior angle of a regular polygon. So one interior angle of a regular polygon is 140 degrees. The word regular, okay, the word regular here means all angles of a polygon are the same, and all the sides are the same. Okay, so whenever you see the word regular in front of the polygon, that's referring to as all sides and all interior angles and exterior angles are the same of that polygon. Is 140 degrees. Find the measure of the sides. All right, so let's see. Remember now, this formula, n minus 2. How many sides minus 2 times 180? Okay, this formula up here actually give me the sum of interior angles. All right, this 140 representing one interior angles. So if you think about it, if I know my sum of the interior angle, then to find one of them, I will just divide it by so many sides I have. So when I divide it by the number of sides, that will actually give me each interior angle. All right, divided by so many sides give me each interior angle. So each one of my interior angle right now is 140 degrees. So that will be n minus 2 times 180 divided by n. So let's solve for n. So by looking at this equation that I want to solve for n, I only got two terms, okay? The whole left side is only one term. So to get rid of the fraction, we will multiply both terms by n, because what I want to do is when I times by n means n over 1, so the top n, bottom n will cancel out. So that will just leave me with what's on the numerator, which is n minus 2 times 180 equal to 140n. All right, so if I do a distribution with my 180, That will give me 180n minus 360 equal to 140n. All right. Since 180n is bigger than 140n, I'm going to move my 140n to the left side. Negative 360, move it to the right. So that will be 180n minus 140n come over. Positive 140n come over to the left side, become negative. Negative 360 go to the right, become positive. So 180n minus 140n give me 40n equal to 360. So here, if I divide both sides by 40, all right, that will give me 9. So that means this regular polygon with each interior angle that are 140 degree, it has 9 sides. Okay, it has 9 sides. All right, find the measure of each one of the angle below. So this is 1, 2, 3, 4, 5-sided shape. So if I have 5-sided, now it's giving me each interior angle. So I need to find what's the sum of interior for 5-sided shape. Once I know that, then I can actually set up my equation, okay, as well. So let me show you. If I take 5 minus 2 times 180, this will give me the sum of all 5 interior angle. 5 minus 2 times 180. All right, 540. Pentagon, 540 degree interior. So let's see. X plus this interior angle, x plus 5, plus this interior angle, x minus 9, plus 96 plus 82. All right, all 5 angle together got to equal to 540. Now, if I set it up this way, then I can solve for x. So I can find these 3 missing angle here. All right, combine like term, x plus x plus x. That's 3x. Let's see, negative 9 plus 96 plus 82. That will be positive 169. Set it equal to 540. All right, I'm going to move my positive 169 to the right side to become negative. So that will give me 3x equal to 540 minus 169, which is 371. All right, divide both sides by, let me make sure I did it right, 169, that's 682, divided by 3. 123.6 repeating. Ooh, this one is a little bit rough. Make sure I did it right. Oh, I'm sorry. Crap, I knew I did something wrong. There's a positive 5 right here. I never encountered it. I never used it. Sorry about that. Let me do this again. All right. I knew I was missing a number. So earlier, the negative 9 plus 96, there's a 5 right here. I forgot to include 5. Minus 9 plus 96 plus 82. There go 174. 174 equal to 540, right? All 5 angles together is 540. So 540 minus 174 is 366. Divide both sides by 3. 122. All right, so x equal to 122. So that means this angle is 122 degree. This interior angle is 122 plus 5, which is 127. This one is 122 minus 9, which is 113. There you go. All right, so So those are the three missing angles. All right, so let's take a look at this. So that was interior angles of a polygon. All right, the concept of similar triangles. Okay, when we're talking about polygons, we always talk about similar figures or similar triangles. So what's considered as a similar triangle is the corresponding angles. Okay, if I got two triangles that are similar, the corresponding angles have the same measure. Similar means something are the same. What's the same is the angles have the same measurement, but the length of the triangles of the corresponding sides are proportional. So this is just another way of saying if I got two triangles, if I can matching up their vertex, okay, if I can match up the vertex first, and each angle, each corresponding angle are also the same, then the sides of the corresponding, the length of the corresponding sides are proportional. That simply means one is bigger than the other. So if I say this is 1, 2, 3, if I say these are the three lengths, okay, and I'm gonna say these two triangles are similar and this one is twice as large. So if I say this is twice as large, this will be 2, 4, 6. So this is what they mean by the length of the corresponding sides are proportional. That just means one is bigger than the other. So we can basically use the concept of proportion, okay, to help us to find the missing side. All right, here it says the length of the sides of triangle ABC are 3, 5, and 7. So let me draw this real quick. If I have a triangle that's called ABC, 3 centimeter, 5 centimeter, and 7 centimeter, triangle DEF is similar to triangle ABC. So here I have a triangle DEF. I want to label similarly like the one I just did. The length of the one side of a triangle is 12 centimeter. What is the largest perimeter possible, all right, for triangle DEF? So if I would say like the D to E to be 12, what is the largest perimeter possible for triangle D to E to F, okay, or triangle DEF? All right, so think about this. If I purposely label A to B is 3 and D to E is 12, so that means I want these two sides to be the corresponding side. So the 12, okay, is actually going to be 4 times. This side is actually going to be 4 times as large as my corresponding side 3. So if this triangle is going to be 4 times as large, the other two sides, okay, will also times by 4 as well. So that will be 20 and 28. So the largest perimeter possible for triangle DEF will be 12 plus 20 plus 28. Right? 12 plus 20 plus 28. So that would be largest perimeter possible is 60. All right. So I'm basically saying my corresponding side 3 and 12 are corresponding and they are proportional. So if that's the case, then I know this triangle DEF is going to be 4 times as large as my original ABC. So we multiply all the sides by 4 and then add up to find the perimeter. All right, let's take a look at this one. All right, Chris was curious about the height of Kiegnam. Okay, Kiegnam. The height of Kiegnam Hanoi Landmark Tower, and decided to measure it indirectly while he was in Hanoi, Vietnam. He used a 2-meter model of the building that he found in a gift shop and measured the length of the shadow of the model to be 1.6 meters. Okay, so the model is 2 meters tall. This is the model. Okay, this is a you know what? Let me do it right this way. So this is model, and this 2 meter representing the building of the model. The 1.6 is the shadow of the model. So that will be 2 meter compared to 1.6 meter. So down here, this is shadow. I'm going to use proportion to set this up. That will equal to, all right, so the top number representing the height of the building, the bottom representing the shadow length. Then he measured the length of the shadow of Kiagnam Hanoi Landmark Tower and found it to be 280 meters. So the shadow of the actual tower is 280, so I'm going to put it down here. What is the actual height of Kiagnam Hanoi Landmark Tower? So that will be X up here. So the actual tower, the actual building, okay, is X. The height of the model is 2. Shadow down here, 1.6 and 280. So here, if I use a little cross product to solve proportion, that's 1.6x equal to 280 times 2, which is 560, and divide both sides by 1.6. That will give me 350. So the actual height, okay, of the tower is 350. All right. So in this lecture video, all right, we briefly talk about polygons and circles. We did some application regarding to the interior angles, okay, of a polygon, and we also talk about area circumference of a polygon. And here we talk about similar triangles or similar figures, okay, of our polygon by using proportion. All right, that will conclude this lecture video on circles and polygons. Thank you for watching.